Good afternoon, guys. So today we are going to start Unit 4. Okay. So Unit 4, in Unit 4 you are having genetic algorithms, learning set of rules, reinforcement learning. Okay. So these are the three chapters we are having in 4th unit. So first we will start genetic algorithms. Just a moment. Wait a moment. Today net is very slow. Please be patient. So can you see the screen? So can you hear me? Guys, can you hear me? Hello?
Yes, ma'am, you're audible.
Can you hear me? Respond something. Can you hear me? Hello?
Yes, ma'am, you're audible.
Okay, right. So as I have told you, your first topic is genetic algorithms. Okay. So first we will see what is genetic algorithm. So genetic algorithm is nothing but it is a learning method motivated by analogy to biological evolution. So genetic algorithms search the hypothesis space by generating successful hypotheses which repeatedly mutate and recombine the parts of the best currently known hypothesis. So if you see here, one second. Just a moment. So here you can see the history of genetic algorithms. As early as 1962, John Holland's work on adaptive systems laid the foundation for later developments in genetic algorithms. So he has worked on adaptive systems. Next, by 1975, the publication of the book Adaptation in Natural and Artificial Systems by Holland and his students and colleagues. So he has published one book in adaptation in natural and artificial systems in 1975. Okay, so early to mid 1980s, genetic algorithms were being applied to a broad range of different subjects. In 1992, John Coase has used genetic algorithm to evolve programs to perform certain tasks. He called this method genetic programming. So he has developed different algorithms with the different programs and he have performed the different tasks. Then he has called it as genetic programming. That is also there. We will see in next classes. Okay. So genetic algorithm is a search technique used in computing to find true or approximate solutions to optimize and search problems. So what we are doing here to optimize search problem, either it will find the search solution or optimal solution. So when we are using genetic algorithm, so it will optimal solution. Okay. So that's why we are using genetic algorithm. So to optimize the search problem, we are using genetic algorithm. Okay. Uh, so here for reproduction. So this particular different algorithms which we will be using good properties, good properties of the algorithm, and we use that properties to reproduce the result. Okay. So here I'll tell you one example. Example ఏంటి అని అంటే if you take in forest లో lions ఉన్నాయి. Okay. Okay. So provincial lions example this one. So take the animal lion. సో అవిటికి పిల్లలు పుడతాయి. సో లాయన్స్ ఏంటి అని అంటే హంటింగ్ చేస్తాయి. సో లాయన్ పిల్లలు కూడా ఏమవుతుంది అని అంటే అవి కూడా హంటింగ్ నేర్చుకుంటాయి. Okay. Okay. So you take the example of lion animal. Okay. So it will so what it will do? It will rigorously hunt the other animals. Okay. So వేరే animals ని వేటాడి తింటాయి. సో ఇప్పుడు లాయన్ పిల్లలు తీసుకున్నారు అనుకోండి, లాయన్ పిల్లలు కూడా లాయన్స్ దగ్గర నుంచి అవి జెనెటిక్ ప్రాపర్టీస్ ని ఇన్హెరిట్ చేసుకొని లాయన్ పిల్లలు కూడా ఏం చేస్తాయి, డైరెక్ట్ అవి వాటికి నేర్పించకుండా అవి ఏం చేస్తాయి, అవి హంటింగ్ చేస్తాయి. ఓకే. కానీ ఆ మధ్యలో ఒకసారి ఏమైంది అని అంటే టూ లాయన్స్ ఫ్రమ్ ద సర్కస్ నుంచి వాళ్ళు ఏం చేశారంటే 2 లాయన్లని వదిలేశారు. ఓకే. సో యాక్చువల్గా లాయన్స్ ది ప్రాపర్టీ ఏంటంటే మంచిగా హంటింగ్ చేస్తాయి. కానీ ఆ సర్కస్ నుంచి వదిలేసిన లాయన్స్ ఏం చేశాయంటే అవి బయట తిరగడం స్టార్ట్ అయ్యి, కాకపోతే అవిటిని హంటింగ్ చేయలేకపోయింది. ఒక దగ్గర వెళ్తూ ఉన్నప్పుడు ఏమైందంటే అవిటి వెనక డాగ్స్ పట్టాయి. డాగ్స్ ఏం చేసినాయి? ఆ లాయన్స్ అన్నిటిని హంట్ చేసి చంపేసాయి. ఓకే. సో ఇక్కడ ఏంటి అని అంటే మామూలుగా ఫారెస్ట్ లో ఉన్న ఎనిమల్స్ కి, ఫారెస్ట్ లో ఉన్న లాయన్ పిల్లలకి ప్రాపర్టీస్ అన్ని ఇన్హెరిట్ అయినాయి పేరెంట్స్ దగ్గర నుంచి. కానీ ఇప్పుడు సర్కస్ లో ఉన్న వాటికి అవిటికి ఏంటి అని అంటే ఓన్లీ ద పర్సన్స్, ఆ సర్కస్ లో పనిచేసిన వాళ్ళు ఏం చెప్తాయో అవి మాత్రమే చేస్తాయి. ఓకే. ఇప్పుడు ఫైర్ నుంచి దుంకడం కానీ, ఓకే, సమ్ డిఫరెంట్ థింగ్ చేయడం కానీ, సో లైక్ దిస్. Okay, so now what is happening here? It inherits the genetic properties from the previous module or from the previous generation. So this is nothing but genetic algorithm. Okay, so genetic algorithm is a learning method motivated by analogy to biological evolution. So here, evolutionary biology, that is nothing but inspired by the nature. So what has happened when we have developed these genetic algorithms? The persons, they have inspired by the nature and they have developed different types of genetic algorithms. Okay, so by inspiration of nature, this was derived or mimicked, seeing some different animals or different things, and derived some basic characteristics and developed it into different forms of algorithms. So those are nothing but genetic algorithms. Okay, and genetic algorithms search the hypothesis space by generating successor hypotheses which repeatedly mutate and recombine parts of the best currently known hypothesis. So what it will do, it will search the hypothesis space అంటే మనకు అవుట్పుట్ ఇస్తుంది. బై జనరేటింగ్ ద సక్సెసర్ హైపోథసిస్ నెక్స్ట్ ఏంటిది అనే దాన్ని కూడా బేస్ చేసుకొని వర్క్ చేస్తుంది జెనెటిక్ అల్గోరిథం. Okay, so what it will do, it itself will mutate, changes, recombine the different parts for knowing to the best hypothesis. So this is done by genetic algorithms. And in genetic programming, entire computer programs are evolved to certain fitness criteria. Okay, so if you see here, set of set of inputs will be given as input. Okay, so this is set of inputs which is given, and then one algorithm is applied on this set of inputs, and you will be getting the set of solutions to your data. Set of solutions. Okay, so here you will be using an algorithm. So here, genetic algorithm is a search technique which is used in computing to find true or approximation solutions to optimize and search problems. Genetic algorithms are characterized as global search heuristics. Genetic algorithms are a particular class of evolutionary algorithms that use techniques inspired by evolutionary biology. నేను మీకు చెప్పినట్టు. So the persons who have inspired from the nature. So they have developed different types of algorithms. Okay, so those are nothing but genetic algorithms. And a genetic algorithm is a search heuristic that is based on genetics and Charles Darwin's theory of natural evolution. Okay, so this is based on Charles Darwin theory. So here, what is Charles Darwin theory? Charles Darwin theory says that the fitness individual among the population is fit to survive in that particular environment only, and individual produce the offspring of next generation with inherited characteristics. So whatever the individual fitness which will be selected, that will reproduce in order to produce the offspring to the next generation. ఇప్పుడు మనం మంచి చేసాం అనుకోండి మన పిల్లలకు కూడా మంచి జరుగుతుంది అని అంటాం చూడండి సామెతలు. సో దట్ థింగ్. ఓకే, సో ఇఫ్ యూ డూ గుడ్ థింగ్స్ in front of your children, so children all obviously they will inherit the properties of you. Okay, so that is nothing but to produce the offspring of the next generation with inherited the characteristics. So it is used to find optimal or near optimal solutions to difficult problems which otherwise would take a lifetime to solve. So it will give us optimal solution or near to that particular uh, optimal solution for different difficult problems also. Okay, so it is frequently used to solve optimization problems in research and in machine learning. Okay, so this process keeps on iterating, and at the end, a generation with the fittest individuals will be formed. So what we are doing, what it will do, it will iterate. One process is done. Okay, in one iteration, it gives us some output, and again, what it will do if the solution is not accurate, optimal one. So again, it will iterate itself, and it gives one more output. Okay, and it will check for the fittest solution. It gives us the fittest solution. Okay, until we get the best solution, it will be iterated again and again. This notion can be applied for a search problem. We consider a set of solutions for a problem and then select the set of best ones out of them. So what it will do? It will take set of solutions for a particular problem and select the set of best ones from from the particular output which it uses by using some algorithm. Okay, from that we will select one best solution. So if you see here, there are different types of search techniques: calculus based techniques, guided random search techniques, enumerative techniques. In calculus based techniques, we will be using the examples like Fibonacci series, sorting techniques, sorting problems, all these things. Okay. So genetic algorithm is one of the technique which is used under random search technique. It is one of the technique which is used under evolutionary algorithm. Okay. So here you can see one example. So in one time, the plants were in some size. అంటే కిందికి ఉంటుంది ఇంతకుముందు చెట్లు. Okay. So then herbivorous animals could eat it. Herbivorous animals ఏం చేస్తాయి? కిందికి ఉండేది చెట్లు మంచిగా తింటుండే. Okay. Now, if you see this particular animal would have struggled hard to survive it in that particular environment. So ఈ animal కి కింది వంగి తినడం చేయడం. So if you take example of giraffe, okay, so కిందికి వంగి తినడం చేయడం. So surviving was somewhat difficult. Okay. So where the plants were at down. But now, if you take the example of giraffe, జిరాఫీ ఏమైంది అని అంటే నెక్ పెద్దగా ఉంటుంది. ఓకే, లాయిన్స్ కి కానీ దేనికైనా కానీ హంటింగ్ ప్రాబ్లం అవుతుంది. ఇట్ విల్ నాట్ హంట్, ఇట్ కెనాట్ హంట్ ద జిరాఫీస్. ఓకే, సో హియర్ what has happened, this animal struggled hard and that come out into the genie. So different animals struggle hard and some output has came in the form of genie. Okay, so which has longer neck. Okay, and with this longer neck it can eat easily. So here if you take the example of giraffe, it is having two advantages. It can raise of height, it can raise its neck and it can eat easily. Okay, and the neck is longer and it is difficult by the predators like lions and tigers to catch and kill them. Okay, so likewise what has happened from the previous uh, inheritance of different animals. So this particular animal has got different characteristic that it has a long neck. Okay, so with that long neck, it can easily eat the trees which are height. Okay, and whatever the predators which are there, they cannot kill them, hunt them. Okay, so like this. So this is nothing but mutation. So this is called as mutation. So this is one type of example. So if you see one more example, okay. So in the previous example, if you see the evolution in giraffe, where it evolved from smaller height to longer height with longer neck. So it can be one of the genetic algorithm where some kind of mutations are done. That is metabolic process gone under them and resulted in getting longer neck. Okay. So that is the process of mutation. So likewise, we are having one more example that is related to traveling salesman problem. Okay. So if you see in this particular problem, the salesperson need to travel from one city to another city to promote his product. Okay. So what he has to do, he has to take care of two things. So here he has to take care of two things. He should not he should travel the minimum distance. This is the first thing he has to take care of it. Second one, he should not repeat one particular city twice or thrice. That is nothing but he has to travel only one city once. Next, he has to go to another city. Okay. So this two things he has to follow if he has to promote his product. Once he travel one city, he has to move to next city only. Okay. So this problem is applied to genetic algorithm. So here, genetic algorithm finds out the optimum solution for this particular problem. If you see here on the screen, one plotted graph is there. In that graph, there are 30 cities. Okay. So genetic algorithm finds the minimum distance and a salesman has to travel once one city only once. సో ఈ వీటిని ఈ ప్రాపర్టీస్ ని దృష్టిలో పెట్టుకొని Genetic algorithm has to give us optimal solution. Okay. So now, if you see, one red dot is there. Okay. So the salesperson has traveled from there, and he has traveled all the cities. 30 cities he traveled this. Okay. So now what is happening here? The algorithm will calculate the distance between all the cities. Okay. So now the data is given to the algorithm. Okay. So one iteration has done. In one particular iteration, the salesperson has traveled up to 940 kilometers. In second iteration, second time, the person has traveled some less time. So likewise, okay. So what it has to give? It has to give us some optimum solution to this particular problem. Okay. So for this type of problems, we will be using genetic algorithms. So here you come across different types of basic terminologies like population, chromosomes, gene, allele. Okay. So what is population? So population is nothing but it is a subset of all the possible solutions to the given problem. The population for a genetic algorithm is analogous to the population for human beings representing human. I'll just tell you the definitions, then I'll give you one example for this. So here chromosome is nothing but it is one solution to the given problem. Gene is nothing but a gene is one element position of the chromosome. Allele is nothing but it is the value of a gene takes for a particular chromosome. So if you see one example, so X is one person, he is having 10 habits. Okay, so those are nothing but chromosomes. So different habits and a writing habit only. Okay, sorry, seeing TV is one habit. Playing something is one habit. So likewise. Okay, so these are different types of habits a person is having. Now I'll take writing habit. Okay, so I'll take writing habit. Okay, so writing habit now. Writing habits. So if you write something, okay, writing in time, I'll give it as 0. Okay. Next, whatever he has taken to write, that he has written fully, I've given it as 1. Okay. Some other thing is there that I have given as 0. Okay. So he is maintaining writing something neatly or not. For that I'm giving 1. Okay. So likewise, you are giving different properties to that particular chromosome. Okay. So 10 habits are chromosomes. In that particular, you have taken one thing that is called as this writing habit is called as gene. Sorry, gene. Okay. And this gene, if you take 0, okay, is 0 then ki writing something, mm, writing in not proper way. Okay. So ఈ జీరో అనేది నేను దేనికి ఇచ్చాను ఈజ్ నాట్ రైటింగ్ ఇన్ ఏ ప్రాపర్ వే సో దానికి నేను జీరో ఇచ్చాను సో టేక్ దిస్ పర్టిక్యులర్ థింగ్ దిస్ ఈస్ కాల్డ్ యాజ్ ఎల్ఈ ఎల్ఈ okay so listen carefully x is a person he is having 10 habits these 10 habits are called as chromosomes in those chromosomes I have taken one habit that is writing habit okay సో రైటింగ్ హ్యాబిట్ జీనీలో నేను ఏం చేశాను వన్ పర్టిక్యులర్ కరెక్ట్ హ్యాబిట్ కరెక్ట్ థింగ్ తీసుకోలేదు దానిని ఏమంటున్నానంటే ఎలి అంటున్నాను ఓకే సో యూ విల్ బి హ్యావింగ్ chromosomes gene allele okay again it is divided into different things like genotype and phenotype. Genotype and phenotype. Genotype is the population in the computation space. In the computation space, the solutions are represented in a way which can be easily understood and manipulated using a computing system. If you take the genotype, so what will happen? We can easily manipulate that. But in case of phenotype, we cannot manipulate it. Phenotype is the population in the actual real world solution space in which solutions are represented in a way they are represented in real world situations. So here we can easily manipulate and here we cannot that much easily manipulate the solution. Okay. So next is general operations of genetic algorithms. So initialize the population. That is nothing but generate P hypothesis at random. So we have to generate different types of outputs, hypothesis and outputs. Okay. Evaluate for each P, compute fitness. So next what we have to do, we have to find which particular hypothesis is best one. Okay. So for that, we have to compute the fitness. While max H, fitness of H less than threshold, do select, crossover, mutate, update and evaluate. Select ante probabilistic select a fraction of the best p's in P. Call this new generation P new. What you have to first select one, okay? Then what you have to do? You have to find whether this particular P is having fitness or not. If it is having fitness, call this as P new. Okay. Then use crossover. What is crossover? Crossover is nothing but you can change the values from one chromosome to another. From one chromosome, from different chromosomes, you can cross over the data, cross over the product. Okay, so that we can see by using one example. In next classes, I'll tell you how it is done. Okay, next is mutate. After crossover, you have to mutate the things. Then update. After that, you have to evaluate whatever the fitness which you have got that is correct or not. So this process is repeated until you get the accurate result, accurate hypothesis. Okay, so the remaining part we'll see. Again, I'll explain the general operations in tomorrow's class by giving one example. So guys, give your attendance here. Yeah, 16 series 523, 16 series 5E2, 17 series 506, 511,
Present, ma'am.
527. Which number? 11 or 27?
11, ma'am.
Huh? 11. 27,
Yes, ma'am. 11.
527, 527, 545, 556,
Present, ma'am.
563, 582, 582, 5C4, C7,
Present, ma'am.
D4, D4, G0, M6, 1, roll number 1, 18 series,
Present, ma'am.
2, 2, 3, 4, 5,
Present, ma'am.
6,
5 present, ma'am.
6, 7, 8,
Present, ma'am.
9,
9 present, ma'am.
10, 11, 12,
Present, ma'am.
13,
Present, ma'am.
14, 15,
Present, ma'am.
16,
Present, ma'am.
17, 17, 18, 19,
Present, ma'am.
20. ఎవరమ్మా 19
19 present.
20, 21, 22,
Present, ma'am.
23,
Yes, ma'am.
24, 25, 26, 27, 28,
Present, ma'am.
29, 29, 30,
Present,
30,
ma'am. 30.
31, 32, 33, 34,
Present, ma'am.
35, 36, 37, 38, 39,
Present, ma'am.
40,
40 present,
41,
ma'am.
41, 42,
Present, ma'am.
43,
Present, ma'am.
44, 44,
Present, ma'am. 44.
45,
Present, ma'am.
46,
Present, ma'am.
47, 47, 48,
Present, ma'am.
49,
Present, ma'am.
50, 51, 52, 53,
Present, ma'am.
54,
Ma'am, 51 present,
55,
ma'am.
55, 56,
Ma'am, 48 present, ma'am.
57,
Present, ma'am. Ma'am,
huh?
51. 51 present, ma'am. Present, ma'am. 57.
Okay,
48, ma'am.
okay.
40, 48.
53 present, ma'am.
Next 58,
57 present, ma'am.
58, 58, 59, 60.
Present, ma'am.
Huh?
Ma'am, 60 present,
What's your
ma'am.
roll number? Okay, next. Okay, next. Right, you can leave, Amma. Okay,